they want to be universal, but
What?
But my way.
my way, exactly.
By the way, if you know about music people, always have these roadies that go with them, and they bring all their equipment with them. This is why, because if you bring, I used to bring my own projector, my own everything, because that way you know exactly what it is and it doesn't mess up. But we'll put up with this. So I'm going to talk about the let's start back here. How many of you have used electronic spreadsheet like Excel? A lot of you. Now, how many of you have run a business with a spreadsheet by hand, like my dad did for his business, his printing business back in Philadelphia? 3, 4, oh my God. Okay, but a lot less people. For those of you who are young, for hundreds of years, this is how it was done. You did it by hand. In early 1978, I started coming up with the idea that eventually became VisiCalc. And it shipped the next year on something new that was called an Apple II personal computer. You could tell that things had really changed when 6 years later, the Wall Street Journal ran an editorial that assumed that you knew what VisiCalc was, and that maybe you would have even been using it 6 years later. They went from no electronic spreadsheets to that. Steve Jobs, looking back in 1990, said that spreadsheets propelled the industry forward. VisiCalc propelled the success of Apple more than any other single event.
It's true.
On a more personal note, Steve said if VisiCalc had been written for some other computer, you'd be interviewing somebody else right now. So, VisiCalc was instrumental in getting personal computers on business desks. What did I go through to make it be what it was? What was the steps that I went through, and can we learn anything from it? Well, I started programming in 1966 when I was 15. About a couple months after this photo was taken. And very few high schoolers had access to computers in those days. But I was very interested in computers. Now, in those days, most guys my age were interested in cars, and they had really interest in cars, they were interested in sports or whatever. I was interested in computers, and that was very unusual. I was really interested in computers, and through a lot of luck and perseverance, I got time on computers around the city. That's what I looked like. You'll notice it's the same jacket I was wearing a few years ago. with a box of punch cards, and this is the type of computers that. After sleeping in the mud at the Woodstock Music Festival, I went off to go to college at MIT. And where to make money, I worked on the Multics project. Now, Multics was an innovative, trailblazing, interactive time-sharing system. And have you heard of Unix and Linux, the operating system? They came from Multics, which was developed just down the block in Tech Square. And I worked on what are known as interpreted computer language systems that are used by non-computer people to be able to do their calculations while seated at a computer terminal. In those days, most of them were printed, used printers. After I graduated from MIT, that's me graduating from MIT, I went to work at Digital Equipment Corporation. At DEC, I worked in a new area called computerized typesetting. We helped newspapers have their reporters replace their typewriters with computer terminals. And I would write software back in the office here in Maynard, Massachusetts. And then I would go out into the field to places like the Kansas City Star, the newspapers, where I would train users and get feedback. This was real-world experience. I was used to living with all the people in my dorm who, as I now a large percentage of them are on the spectrum. And I was used to being with computer programmers. And this was quite different. Newspaper people were quite different. And I got to help train them and get feedback from them. And it was real-world experience. It was quite different than what I saw in the labs over here at MIT. Getting experience to how they thought. And After that, I was project leader of DEC's first word processing system. Just like it was also a new area, this was one of the first word processors out there, screen-based word processors. But just like in typesetting, the key was crafting a user interface that was natural and efficient for regular people to be able to use, for non-computer people to use. After that, I went to work for a very small company that made electronic microprocessor-based cash registers for the fast food industry. This was but I always wanted to go into business. I wanted to go into business with my friend Bob Frankson, who I met when I worked on the Multics project at MIT. But I wanted to learn about business. So in the fall of 1977, I started the MBA program at Harvard Business School, where I was one of the very few people who had background in computer programming. Here is a picture from the yearbook of me sitting in class. At Harvard, we learned by the case method. Cases, we do about 3 cases a day. Cases consist of up to a couple dozen pages, laying out a particular business situation, and they often have exhibits, and exhibits have words and numbers laid out in ways that make sense for a particular business situation. Here's my homework, the same type of thing. You'll see, this is what I'm experiencing. This type of different ways of doing that. Lots of calculations. We got really close to our calculators. But this is my calculator. For Halloween, I dressed up as a calculator. At the beginning of each class, the professor would call on somebody to present the case. That person would explain what's going on and then dictate information that the professor would transcribe onto these many moving motorized blackboards at the front of the class. And then we'd have a discussion. One of the really bad things is you come into class and you find out that you made a mistake and all your numbers are wrong and now you can't participate. And we were marked on class participation, 50% class participation. So I'm sitting there with 87 other people in the class, and I got to daydream a lot. And now most programmers in those days, they worked on mainframe computers. Those are the big computers, and they worked on things like inventory systems, and payroll systems, and bill paying systems, and stuff like this, and stuff like this, but I was working on interactive word processing and on-demand personal computation. So I was thinking differently than that. They were thinking paper and punch cards, and I was thinking interacting with a computer. In fact, I imagined that there was a magic blackboard. I imagined this magic blackboard that when you wrote on it and then changed the number, erased and changed the number, all the other numbers would change. Kind of like word processing with numbers. I imagined that my calculator had mouse hardware on the bottom of it and a head-up display, like in a fighter plane where you could see the numbers. And I could type some numbers in, circle it, and push the sum button, and get the answer right in the middle of the negotiation. Now the problem was how to take my fantasy and turn it into reality. My father taught me about prototyping. What he would do is he would make up these prototypes where he'd paste up stuff to figure out how to lay out type on a page. And then he would show it to the customer to get feedback and to get an okay before he'd send it off to the printer. So he said, well, you okay that, this is what it looks like. The act of making a simple working version of what you're trying to do helps you be able to discover key problems and solve them less expensively early on. Prototyping is real important. So I decided to build a prototype. I found a computer terminal at Harvard, a time-sharing system there, that time-sharing system, and I got to work right making a prototype of this idea. Now, one of the first problems that I ran into was, how do you represent values in a formula? Let me show you what I mean. This would be the screen, and I thought you'd point somewhere, and you type in some letters, and then you point somewhere else, and you type in some numbers, and point somewhere else, type some more numbers in, point to the last place where you want the results, the first, plus minus, point to the last. and then you get your answer. The problem was, what should go into the formula? It had to be something that the computer would be able to use, and you needed to know where it referred to on the screen. So, I'm a programmer, thinking like a programmer. What's the first thing I think? Well, let's have the computer ask you. The first time you would put something in, it would ask you to type in a unique name, and then that's what you would use. That's what you would use. Now, this clearly became very tedious when I tried it out, and I also realized real people aren't going to do like programmers and make up unique names, the concept of unique name. And all these things weren't going to work. It had to be that the computer could automatically come up with the name and be able to use it. So I said, well, why don't we do it the order in which you create them? So you would have value 1, value 2, etc. Great idea. Well, that very quickly I found out I couldn't remember them all. Clearly, normal people would not put up with this. Okay. So I thought, well, rather than allowing you to put things anywhere on the screen, why don't I restrict you to a grid? And then, when you clicked on something, the computer could put in the row and column to be able to say what it was. And if I put letters across the top and numbers down the side, if you saw B7 in a formula, you know exactly where it was on the screen. And if you had to produce your own formula, you knew exactly what to type in. Restricting to a grid helped solve my problem. It also provided some other things. So, for example, I could do ranges of cells to be able to do like sum from here to there. However, it wasn't too